Welcome to episode 485 of AI Brief. Today, we are analyzing a really massive paradigm shift across the industry. We're going to be unpacking OpenAI's leap into autonomous digital workers with GPT 5.5, a pretty surprising leak of Anthropic's Mythos model on a private Discord.
Oh, and SpaceX's massive $60 billion play for the AI coding startup Cursor.
Right. Plus, we'll dive into the rollout of ChatGPT's new Workspace Agents, take a deliberate look at the day's other major AI news, and wrap up with the top trending tools you can actually deploy right now.
The overarching theme connecting all of this today is really the transition from just, acceleration to actual execution. We're moving past models that simply help you type faster into an era of systems that autonomously complete the whole task.
Yeah, think about when you hire a new employee. You have that initial honeymoon phase, right?
Right.
But then comes the real test where you hand them their first major messy project.
Right, the ambiguous stuff.
Exactly. You want to hand them an objective and trust they won't come back 5 minutes later asking where to find the server credentials or how to format a data table. And for the last couple of years, AI has basically felt like managing an employee who needs endless hand-holding.
Oh, completely exhausting micromanagement. You had to engineer every single prompt.
Yes, coaxing the machine through every micro-step. But that dynamic is completely fracturing today with OpenAI's release of GPT 5.5.
It really is. They've designed what is arguably the most natively agentic model to date. It is engineered from the ground up to handle multi-step, unstructured tasks end-to-end.
Just huge for enterprise.
Massive. I mean, we are looking at a system that formulates a long-term plan, selects the right software tools to execute it, checks its own work against the original goal, and actually persists through unexpected errors without stopping to ask you for guidance.
I really want to look closely at the mechanics there because the benchmarks are just staggering. It scored an 82.7% on Terminal Bench and an 84.9% on GDP val.
And Terminal Bench specifically measures how well a model can navigate a command line interface on its own, right?
Yes, so scoring nearly 83% means this model can dig into a directory, find missing dependencies, run test scripts, read the error logs, and rewrite its own code to fix the bugs.
Wow.
Entirely unsupervised, it's basically operating with the reliability of a highly competent junior software engineer.
The architectural shift enabling that reliability is what really fascinates me, though. In earlier models, complex reasoning required the system to sort of think out loud.
Right, generating those massive chains of intermediate text tokens.
Exactly. You had to force it to detail its step-by-step logic before it could reach the final answer. But GPT 5.5 is fundamentally different. It matches the serving speed of GPT 5.4, but it uses significantly fewer tokens to accomplish the exact same complex tasks.
Which feels entirely counterintuitive. I mean, in transformer architectures, more reasoning typically demands more tokens, which eats up compute time and drives up your API costs. So my theory is that OpenAI has somehow managed to push the reasoning process deeper into the internal latent space.
That makes a lot of sense.
Yeah, instead of relying on linear, discrete word generation to process a thought, the model's internal layers have been optimized to process parallel reasoning vectors. It finds the solution internally before it ever begins generating text.
Well, your deduction aligns perfectly with the performance metrics we were seeing. The model has internalized those complex reasoning pathways.
Which is incredibly efficient.
Highly efficient. It bypasses the need for verbose token generation, creating a much more direct mathematical path to the correct conclusion. And generating fewer tokens means less compute overhead per task.
Right, improving the unit economics.
Exactly. For any enterprise trying to run these agents at scale, it's a game changer. It shifts the AI from a conversational partner to a high-efficiency execution engine.
But, the infrastructure required to deploy these execution engines is becoming just as complex as the models themselves, which is creating entirely new vulnerabilities.
Oh, absolutely.
We saw a really stark example of this today with Anthropic's unreleased model, code game Project Glasswing, or Mythos. This model was intended solely for select partner deployment on April 10th.
And then it leaked.
On the exact day of its release, access to Mythos leaked to a private Discord group. And the irony here is so thick. You have this incredibly advanced, highly protected technology, and it wasn't compromised by a sophisticated nation-state breaching Anthropic's core servers.
No, it leaked because the deployment infrastructure was fundamentally predictable.
Exactly.
Infrastructure predictability is the Achilles heel of enterprise software. This Discord group, which tracks unreleased models, gained access by simply guessing the deployment URL.
Just guessing it.
Well, they analyzed naming patterns exposed in the recent Merkur breach. In corporate environments, URLs follow strict conventions, something like production model name version 2 UCIST.
Ah, so once you understand the syntax, you just slot in the new code name.
Precisely. You extrapolate the exact URL for the new server.
Add to that the fact that one of the Discord members reportedly possessed active vendor credentials from some contract work. So they had the authenticated key and they deduced the correct door.
It highlights a massive blind spot. The perimeter is no longer just the AI lab's internal security team.
Right. It stretches across every third-party vendor, every contract developer, and every predictable string in a URL directory.
And securing that sprawling perimeter takes immense capital.
Yeah.
But honestly, the capital required for security pales in comparison to what's needed for raw computing power.
Which brings us to the monumental business move between SpaceX and Cursor. SpaceX has locked in an option to acquire the AI coding startup Cursor for $60 billion by the end of the year.
With $10 billion guaranteed immediately.
Yeah. And I have to challenge the fundamental logic of this acquisition. I mean, Elon Musk already controls his own AI company, xAI, and its underlying model, Grok. And just last month, xAI successfully poached Cursor's lead engineers, Andrew Millick and Jason Ginsberg. Musk has the talent in-house. Why write a $60 billion check to acquire an outside product instead of simply building a frontier coding tool internally?
Because in the current landscape, time is the absolute most expensive currency. Throwing engineers at a structural deficit does not yield immediate results.
Fair point.
Over the past year, xAI has been undeniably losing the coding race to Anthropic and OpenAI. Grok simply doesn't possess a native coding environment that can compete with what Cursor's already perfected.
So it's a shortcut.
Exactly. By executing this acquisition, SpaceX and xAI instantly swap a slow, multi-year internal development cycle for an immediate world-class product. They level up overnight.
And on Cursor's side of the equation, the bottleneck wasn't software, it was hardware. Cursor's CEO openly stated that every time they developed a more advanced version of their composer models, they slammed into a compute ceiling.
They had the math, but not the silicon.
Right. By plugging into SpaceX's Colossus infrastructure, which is one of the most massive computing clusters on the planet, Cursor completely eliminates its hardware constraints. It is the ultimate fusion of software brilliance and brute force computing power.
And that fusion is precisely what enables these highly advanced coding capabilities to be compressed and delivered directly to your daily workflow.
Like what we're seeing with Workspace Agents.
Yes. OpenAI is rolling out these new Workspace Agents inside ChatGPT and Slack. They are shared autonomous bots powered by the Codex infrastructure in the cloud, specifically engineered for collaborative enterprise tasks.
The distinction between this rollout and the consumer-focused GPT store from 2023 is really crucial. The original custom GPTs were entirely stateless and siloed.
Right, isolated to a single user.
You used a prompt, got an answer, and the interaction ended. But Workspace Agents operate on shared state memory. Because they live directly inside a team's Slack channel, they observe the ongoing context of the entire team.
They retain memory of decisions made yesterday, and crucially, they can execute offline schedules.
That offline scheduling mechanically changes how you use the software.
Completely. You are essentially setting up continuous cron jobs powered by AI. A sales team can deploy a workspace agent to conduct account research. And while the team is completely offline, the agent continuously monitors target accounts.
Synthesizing breaking news.
Right. And it autonomously drafts highly contextual follow-up emails, just waiting in the queue for approval by the time the human reps log in.
I actually know accounting teams already deploying this for end-of-month reconciliations. The agent pulls the ledger data, cross-references it with banking APIs, flags anomalies, and prepares the journal entries.
By embedding these agents directly into where teams communicate, OpenAI is transforming AI from a solitary web interface into an active, always-on coworker.
It really is maintaining the operational heartbeat of the business. Let's deliberately slow our pace here for a moment. The relentless velocity of this industry often obscures the deeper structural shifts happening beneath the headline announcements. I want to systematically analyze a few key developments today that reveal exactly where the foundational technology is heading.
The friction of integrating these foundational tools into daily work is highly sensitive. Anthropic experienced this today when they temporarily removed access to Claude code for some users on their Pro tier.
Anthropic characterized this as a small test of their sign-up flow, but the immediate backlash from the developer community was palpable.
It proves how deeply embedded these specific coding models have become in daily deployment pipelines. When a model vanishes even temporarily, enterprise development grinds to a halt.
And the hardware powering those pipelines is undergoing a radical evolution too. Google just unveiled their 8th-generation tensor processing units, or TPUs.
The critical engineering decision there is that Google physically separated the training architecture from the inference architecture. They built two entirely distinct chips.
Which solves a massive hardware bottleneck. If you look at the mechanics of serving a model, inference is heavily bound by memory bandwidth. The chip needs to constantly move data in and out of high bandwidth memory to serve a response quickly.
Training a model, however, is intensely compute-bound. It requires massive parallel matrix multiplications over weeks or months.
Historically, silicon manufacturers tried to build monolithic chips that balanced both workloads. But as we enter this era of constantly running autonomous agents, the volume of inference requests is exploding.
By designing an architecture exclusively optimized for memory bandwidth, Google drastically reduces the latency and the cost of serving agentic loops at a global scale.
And that level of targeted optimization is happening in the creative domains as well. Ideogram just launched Custom Models, which allows users to fine-tune the weights of their image generation system using an incredibly small dataset of just 15 to 100 personal assets.
Instead of relying on complex prompt engineering to force a generic model to approximate your brand, this utilizes low-rank adaptation techniques.
To natively embed your specific brand guidelines, color palettes, and product dimensions directly into the model's parameters.
It fundamentally changes creative consistency. If the model inherently understands the exact geometry of your product, you can generate an infinite array of marketing materials without hallucinating the core asset.
And looking at hallucinations, the video generation space took a massive leap today with Odyssey introducing Odyssey 2 Max. This is a world model 3 times larger than its predecessor, and it just topped the industry benchmarks for real-time physics.
A world model that comprehensively maps physics is the absolute holy grail for video generation. Most AI video currently morphs or distorts over time because the system is simply guessing the next pixel based on visual patterns.
Right, but if the underlying architecture inherently calculates gravity, mass, momentum, and object permanence, the generated output ceases to be a predictive visual hallucination.
It becomes a mathematically accurate simulation of reality.
Finally, we have to look at the open source landscape, where Alibaba's Qwen team released Qwen 3.627BB. This is a 27 billion parameter model that remarkably just outperformed its own 397 billion parameter predecessor across top coding benchmarks.
A model less than a tenth of the size, beating its massive predecessor, fundamentally proves that brute force scaling is no longer the only path forward.
By utilizing intense data curation and advanced distillation techniques where you use a massive model to generate highly filtered synthetic data to train a smaller, denser architecture, we are rapidly approaching the point where frontier-level intelligence will run locally on standard hardware.
The compression of these technologies is translating from research papers into practical products faster than we have ever witnessed.
Let's bridge that gap for you. We are going to look at the trending tools today that take all of this complex architecture and turn it into software you can actually deploy.
We already explored OpenAI's Workspace Agents and Ideogram's Custom Models, but the ecosystem is expanding rapidly.
OpenAI also released ChatGPT Images 2.0, upgrading the native image generation directly within their chat interface for much higher fidelity outputs.
And for massive organizations trying to manage this influx of technology, Google launched the Gemini Enterprise Agent Platform,
which provides the secure orchestration layer required to build, govern, and monitor hundreds of specialized agents operating across an enterprise environment simultaneously.
On the multimedia front, a tool called Ella is gaining massive traction. It consolidates the entire latent space video editing pipeline.
Instead of generating a clip in one program, upscaling it in another, and editing it in a third, Ella provides a unified interface to generate, manipulate, and export AI video seamlessly.
Similarly, Somio is pushing the boundaries of acoustic modeling. It allows you to input basic text prompts or lyrics, and it synthesizes the full multi-instrumental melody and vocal tracks entirely from scratch.
The friction between having an idea and producing the final asset is nearing zero.
We're seeing tools like Claras, which utilizes retrieval-augmented generation to let you instantly transcribe hours of YouTube video and chat directly with the context of the transcript.
Or Toki, an autonomous planner that leverages long context windows to map out, organize, and manage your daily calendar and task priorities dynamically.
Exactly. A single individual can effectively operate with the creative, analytical, and operational output of a Fortune 500 company, simply by managing a specialized fleet of these digital workers. The global economy is about to be reshaped by people who know how to orchestrate intelligence rather than just generate it.
Please follow the podcast on your favorite platform and share it with a colleague.